my name is Cordelia Isabel, and I'm a student at Pomona College in Claremont, California. This summer, I had the privilege of working in Dr. Arthur Tinoco's lab during the REU PR Climb Tumor program, and while I was there, I studied the serum transfer and coordination of titanium-4 as a pathway for insulin-enhancing type 2 diabetes. My research dives into how titanium could possibly enter the cell using the ion uptake system of serum transferrin and the role of the synergistic anions facilitating that uptake. By analyzing the thermodynamic and thermal stability of the titanium-4 coordinating with the protein serum transferrin, this research has potential to lead to studies of titanium being a metal for insulin enhancement, which directly connects to the treatments for type 2 diabetes, a disease that affects over 450 million people worldwide. So leaving with this idea that research has broader impacts, I just wanted to recognize all the cancer research, specifically breast cancer research, and give a shout out for breast cancer awareness this month.
Hi, my name is Catherine Lemoyne, and I'm a senior at Case Western Reserve University. This past summer, I worked in the lab of Dr. Jose Rodriguez in the Department of Biology at the University of Puerto Rico, Rio Piedras, as a part of the REU PR Climb program. Our research focused on mutations in transcription factors that can cause congenital heart defects. When mutations occur, they prevent the heart from developing properly. In fact, 1 out of 100 babies are born with congenital heart defects. Our goal was to learn more about the impact of some of the mutations that have been observed in patients, which we did through protein purification and binding assays. Scientific research is the first step to medical breakthrough, whether it is in heart disease or cancer. That is why I'm happy to join everyone supporting Breast Cancer Awareness Month this October.
Hi everyone, my name is Colby Agostino, and I'm a senior at Providence College in Providence, Rhode Island. During my time at the REU PR Climb program, I worked in Dr. Zhongfeng Chen's laboratory in collaboration with Dr. Arthur Tinoco's research group. During the REU, I used the Gaussian 09 package, which is a type of computational chemistry software, to investigate deferoxyrox, which is an iron chelator, meaning that it's an organic compound that binds iron and is currently being used to treat iron overload disease. Throughout my research, the goal was to determine the equilibrium constants for the complexation of deferoxyrox with various metals. And this essentially tells us how strongly deferoxyrox binds different metals. And this research is important because we hope that it will provide insight into the mode of binding that occurs between copper and deferoxyrox, which has been pretty elusive in experimental studies. And if we are able to determine this mode of binding, we could use deferoxyrox to treat diseases in which copper is implicated, which are primarily neurological disorders such as Wilson's, Alzheimer's, and Parkinson's disease. Before I finish up, I just want to give a quick shout out to breast cancer awareness. Ironically, my research stemmed from a project investigating the possibility of using deferoxyrox to selectively inhibit the growth and metastasis of cancer cells. And like everyone else, I hope that research pans out. Thanks again.
Hello, my name is Valerie Banky, and I am a senior majoring in biochemistry and Spanish language at the University of Mary Washington. During the REU program, I had the absolute pleasure of learning and developing my scientific research skills under the mentorship of Dr. Arthur Tinoco and co-mentorship of Andrea Mazer. The grand scope of our project is focused on the development of a new bio-inspired drug design strategy for metal-based therapeutics in the field of cancer studies. Specifically, I explored the affinity properties for metal titanium-4 complex and the FDA-approved iron chelator deferoxyris. This metal-based drug, known as titanium deferoxyris, is of great interest as a potential cytotoxic anti-cancer agent. I also investigated titanium deferoxyris effects of copper in the blood by conducting an in situ transmetallation study with deferoxyris, titanium deferoxyris, and copper-bound serum albumin. And so serum albumins are one of two major forms of copper in the blood. This was of great importance because iron 3 and copper 2 are critical for an array of functions in the human body, and it plays a vital role in the biological vulnerability of cancer cells. Cancer is an umbrella term that includes a multitude of diseases caused by various factors, and my research this summer has contributed to why the design and the preparation for anti-cancer compounds, such as titanium deferoxyris, explores the capability of improving current anti-cancer drugs. With that being said, I believe that Breast Cancer Awareness Month is an important campaign to raise awareness about the impact of breast cancer. And it also provides a supportive community towards people affected by breast cancer. Thank you for this opportunity.
Hi, I'm Estelle Strangmark. I'm a senior at the University of Pennsylvania, and this summer I was a PR climber at the University of Puerto Rico. I had the immense privilege to work under Dr. Tinoco in the Tinoco Laboratory on a project to develop a novel anti-cancer drug. And the way that this drug worked was it attacked one enzyme's activity, particularly ribonucleotide reductase. And this is the enzyme that is responsible for cancer cells' rapid multiplication and division, right? So I think what I loved so much about this project was although Dr. Tinoco is an inorganic chemist, the project really spanned a number of different fields in chemistry. I worked with organic synthesis, electrochemistry, obviously coordination chemistry, and there was even a touch of crystallography involved as well. So I think in the spirit of all of the anti-cancer research that I did this summer, I've also really developed an appreciation for anti-cancer research and awareness itself. And I think it's so important here in October that we take time to acknowledge all the people that have been affected by breast cancer and the people that are working to stop that disease's growth. So yeah, I think it's really important that we just take a moment to appreciate it.
Hi, my name is Megan Thomas. I'm a student at the University of Texas, and this summer I did research under the direction of Dr. Vomali Lopez Mejias as part of the Crystallization Design Institute. In my lab, we focused on osteolytic metastatic breast cancer, designing a 3D model that would more accurately represent the bone microenvironment to test the effectiveness of proposed cancer treatments in an in vitro cytotoxicity assay. Testing cancer treatments is limited to how well we can replicate the natural environment where cells are located. With the development of a 3D model of the bone microenvironment, we can allow for cells, both metastatic cancer cells and bone cells, to interact with each other and with the treatment, as they actually would in the body. This results in improved testing of treatments, which helps to catalyze the development of new and effective treatments to fight against cancer. We've made a lot of progress in breast cancer treatments, but it's important to know and recognize how much further we have to go. For example, about 1 in 8 women will develop breast cancer in their lifetime. If the cancer metastasizes, it cuts the 5-year survival rate by almost 75%. With continued research, we can hope to improve these statistics with the goal of making breast cancer a thing of the past.
Hi everyone, my name is Samantha Musso, and I am currently a senior at Marist College in Poughkeepsie, New York, where I am studying biochemistry. This summer, I had the wonderful privilege of working in the Peterson Breast Cancer Laboratory under the direction of Dr. Esther Peterson and Keishla Rodriguez, my co-mentor. The project I was working on was entitled The Anti-Cancer Effects of Cholesterol Against Triple-Negative and HER2-Positive Amplified Inflammatory Breast Cancer. Because of the lack of effective therapeutics that currently exist to treat inflammatory breast cancer, specifically ER-negative inflammatory breast cancer, the long-term goal of this research is to develop effective targeted therapeutics that can be used either as a monotherapy or in combination with other treatments. Specifically, the objective of my research from this summer was to evaluate the potential cytotoxic activity of cholesterol on inflammatory breast cancer. Here's to finding a cure for breast cancer, especially rare forms of breast cancer like inflammatory breast cancer.